Yes, good, I'm on time. Hello, kind people. How are we doing today? I'm chilling, maxing, relaxing, trying to balance the schedule that's on crazy. But I'm here. I'm alive. I'm happy. How's everybody doing today? You good looking? No, not bad. Not bad. That sounds like what, 15 years ago? Yeah, people still do that. For poetry, I think. Yeah. All right, all right. All right, so we don't have a lot to do today. I have two key announcements. The first announcement is that our test is next week, Monday. To take the test, you will need to bring your laptop because the test is being delivered through the laptop. Yes. What I need you to do is go on to what they call a thing in WebAssign and then download the lockdown browser so that you have access to that lockdown browser. All right. Question there. Yes. Yes, you will need your calculator. I prefer you guys don't use your cell phones. But aside from that, remember that there is a practice on there. And also, I guess I should show you this as well. If you go into the course, I gotta sign in again. But if you go into the course, this one's section 8. You go into the modules. And so we unit 1 right here. If you go into the last one right here, what you see right here is you see a recording for the test 1 review. And so you can watch that as well. If you want to know what's covered on the test, you just need to go to each week, and each week shows you the sections that we covered. And so that'll give you an idea of what you need to study for the test. All right. Question there. There's also a practice on WebAssign, I believe. There's also a practice test on WebAssign, if I remember correctly. That's the final exam. Is there a practice? I can't remember. But if not, just going back over your homework will suffice to get you ready. Yeah, I guess not. To get you ready for the test. I guess the review is the video that you need to watch. The other announcement, so the test is in 1 week. The announcement, we will not have class on Friday. I will be out of town on Friday, and so we will not have class on Friday. Questions there before we begin? Yes. Questions there before we begin? Oh, one last thing on class on Wednesday. The main thing we'll do is I'll first answer questions, and then if I'm done answering questions, I will start the next unit. All right. So if you have any questions, I'll try and answer those on Wednesday. You can also come to my office hours on Tuesday and Thursday as well if you need any extra help. All right. The only thing I don't want you to do is wait until Saturday or Sunday evening to start preparing for the test. Yes? That's the only thing I don't want you to do. I want you to be ready, sleep well, come here rested and ready to go. All right. Last time we did percentiles. Somebody remind me, what is a percentile? It's a median is an example of a percentile. A percentile is a measure of relative position. Yeah? All right, let me rephrase the question. If I said on a test, I am at the 95th percentile, what am I trying to say? I scored better than 95% of the students. That's my relative position. If you put us all in line, and then basically the person at the beginning is 0 and the person at the end is 100, then that tells you an idea where I'm placed along that line. I'm 95th percentile, 95th position per se. Yeah? Question there. That also means that 5% of people did better than me. Yeah? Question there. The percentiles run from 1 to 99. You do not want to be in the first percentile, unless, of course, that's the percent of people who did badly, for example. You want to be in the first, because that means you do the best. Yes? Anywho, so after we did percentiles, we looked at the 3 key special percentiles, the first quartile, the second quartile, which is the median, and then the third quartile. For example, if I'm at the third quartile, that means 75% of students did worse and 25% did better. Yes? Yes? I showed you how to calculate those on SALT as well. You guys know what I mean when I say SALT? Statistical analysis and learning tool, I think it's something like that. Web of Science creates that tool for us. And then the last thing we did right here was how to find your quartiles by hand. Normally for large data sets, we let a computer do it. Yes? But the way we find the 3 quartiles is by finding 3 medians. Yes? You first find the median for the whole data set. That gives us the Q2 for the whole data set, which gives us the median. Then we look at the lower half of the data set and we find that median. That's the first quartile. And then we look at the upper half, and that gives us our third quartile. Questions there? We then create something called a 5-number summary. Yes? Where is my 5-number summary? Oh, I missed it. But your 5-number summary is your 3 quartiles along with your highest and your lowest values, your lowest and your highest values. Yes? Those 5 together is what we call a 5-number summary. Okay? And that's kind of where we start. Questions there? All right. So we have one last thing to do. And that right here is something called the interquartile range. The name is supposed to kind of give you an idea of what we're trying to find. When I say range, remind me how you find the range. Subtract the highest from the lowest, or the lowest from the highest value, correct? So if I say interquartile range, what am I trying to ask you to find? The range between the quartiles, yes? And so you're going to take the highest quartile, which is Q3, and subtract the lowest quartile, Q1, and that gives us what's called the interquartile range. Questions there? It's a range, highest, and lowest, yes? But this time we're using the quartile. The important thing about the interquartile range is that it gives us the middle half of the data. Right? Q1 is 25%, Q3 is 75%, yes? Right? Therefore, there's a 50% split right here. That's going to be the data that's right in the middle. Questions there? The other thing about the quartiles and the interquartile range is that it gives us a different way of figuring out if a number is an outlier. Remember we did a little bit earlier on? Remember the calculation to tell there's a boundary. If it's above that, it is an outlier. If it's below, it's an outlier. Yes? This right here gives us a second method for determining if a number is an outlier. And that method is to find the upper outlier boundary. You take Q3 and you go 1.5 times the interquartile range. That gives us an upper boundary. Any number greater than this amount is said to be an outlier. Does that make sense? And then you have your lower boundary, which is going to be Q1 minus this time 1.5 IQR. Any number lower than that boundary is going to be any number lower than that is going to be an outlier as well. Question there. Now, you guys know what an outlier is? Anybody knows what an outlier is? An outlier is a number that seemingly does not fit the data. That's what an outlier is. A number that's either extremely large or extremely small, a number that does not fit the data. Yes? But the thing is that there are basically two kinds of outliers. One, there's an outlier that naturally occurs. For example, if I'm going around picking random houses in Tallahassee to get the value of the house, I pick the first house, 250,000. I pick the next house, 350,000. I pick the next house, 275,000, and I pick the next house, 1.5 million. Yes? That is an outlier, right? Most houses in Tallahassee are between like 200 and say maybe 500,000. Yes? Most houses are in that range. Yes? But 1.5 million right now, that's actually a naturally occurring outlier. Some crazy person just decided that they wanted to live in the best house ever. I think there's one of them that has like 7 rooms, and each room has basically everything that a house needs. It's closet, kitchen, bathroom, everything they want, right? It even has a helipad and everything. Yeah, right? Somebody just felt like they needed a mansion. That's what we call naturally occurring outlier. And the other kind of outliers are errors. Someone was supposed to enter a temperature of 83.5 and they entered 8.35. Yeah, that would end up being an outlier. And so the key thing right here when it comes to data science and statistics is that outliers need to be investigated. You don't simply say it's an outlier and throw it out. You go back and look at the data stream. How did I get to this number? Where did this number come from? And then try to figure out if it makes sense or not. Yes? So for the house that costs 1.5 million, I might look up its address and then go to Google and then pull up the building and say, this building is huge. This is a fine number, right? And as for the temperature data, I might go back over the temperature data and go to a different source, like go to the federal database and pull up the temperatures there and see if the temperatures are the same. Yes? And then I see, wait a minute, the federal is saying it's 83.5 and I have 8.35. I know that this outlier needs to be correct. Questions there? Comments, queries, concerns? What's the formula of finding the upper boundary using the IQR for the outlier? Take the third quartile and then add 1.5 times the IQR. Yes? The lower boundary is take the first quartile and subtract 1.5 times the IQR. Questions there? All right, cool. And so they have an example right here. Oh, they stole my temperature example. All right. What happens? They took the numbers right here, and then they kind of did your lower boundary calculation, and then they figured out that the 8.45 is outside the boundary. And then when they investigated the number, they recognized that this most likely is an error. Questions there? All right, so we have these numbers right here. We plug them into our handy dandy calculator, and then we get the Q3 as 59, and then the Q1 as 45, and so the interquartile range is 14. Yes. And then the boundaries are take Q1, 45, multiply 1.5 times 14, subtract it, 24. And this right here is my cutoff value. Any number lower than 24 is an outlier. If I look inside here, do I see any number lower than 24? Then this means this has no outliers on the negative side. Yes? And then I do again, Q3 times plus 1.5 IQR. So again, that's 59 plus 1.5 times 14, that's 80. And do we see any numbers that are greater than 80? You do. And so this number anymore, yeah, this number right here is an outlier. Okay. Question 10. And in this example, since this right here, the number of students absent right here in the middle school right here, this might be a day that we go back and check what happened. And may have been that this was the day they had a school field trip, right? And then most people just decide not to send their children, so they just stayed home. Yes? And so this would be a naturally occurring outlier if that's what happened. It could have been, though, that this was the day we had a technical glitch. And a lot of people who submitted their attendance, it got deleted or it got changed. Yeah? And so this would be an error that we need to go and fix. Question there. And so the number 100 is an outlier. Questions there? Yes. Yes, ma'am. How did we get that? So again, listen to the name interquartile range. What's a range? A range is take the highest value and subtract the lowest value, correct?
I understand how they got 14. But looking at the numbers, like how.
Oh, so they had to do the hard way. They had to write each number down in order of size from lowest to smallest. And then they had to find the median. And then that's split into two, and then go ahead and find the median for the lower set of data, the median for the upper set of data. Right? But normally the instructions are for this larger number set, don't do it by yourself. Put it into salt or put it into something else and let it do it for you. Right? Because that will just take forever, yes? Right? And so that's not the expectation, is not for you to do it by hand. Anybody else? Anybody else? But if it's a small data set like the one we had on our practice 13 numbers, you can do that by hand. Yes, ma'am.
I would like to listen. Okay, so like looking at this, I'm just confused. Like as to why it was 59.
59 minus how much? 45?
Yeah.
Yeah, so what happened is that the interquartile range is trying to capture the middle 50% of the data, yes? And so what happens is that we're finding a range, yes?
Okay, got it.
And so a range means to subtract the higher from the lower number. So we're subtracting Q3 from Q1. All right? All right. And so here we go, our 5-number summary. We talked about this already. If you were to draw out the 5-number summary, we do something that's called a box and a whisker plot. A box and whisker plot looks like this. If it's horizontal, no, if it's vertical, they can also draw them horizontally. In the box and whisker plot, you give 5 numbers. The 5 numbers are the lowest value, Q1, the median Q2, Q3, and the highest value. All right. It's a way of looking at the data to kind of tell if the data is skewed to the left or skewed to the right. If each of the boxes are approximately the same size, it's a well-balanced symmetric data set. If one side is much longer than the other, then it's skewed to that side. All right? Questions there? All right, so that's the last thing we need to do is to draw a box and whisker plot. Hold on. So I have some data right here. 2, 3, 3, 4, 5, 6, 8, 9, 11, 20. Actually, let's do it differently. Go ahead and log on to Canvas. Let's do it differently. Log into your assignments, and then you should see this assignment right here, measures of spread. We'll go ahead and do that assignment today in class. Why does it need my passcode again? Oh, it does not. And so right here, this passcode right here gives you these numbers right here. Well, my numbers are different. So I guess I could just do this one last one quickly right here. So let me go back right here. So this data set that I have right here, this data set I have right here, I can draw a box and whisker plot for this data set right here. Let me show you how. So let me just write myself down. So the smallest value, the minimum value is 2. The Q1 is 3, the Q2 is 6, the Q3 is 11, and then the max value MAX is 20. What you simply do is you draw a number line. My number line is not very pretty. I do apologize. And then I start, I guess, at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 0, 1, 2, and then 3, 4, 5, 6. Right? And so I just plot the numbers that I needed on a number line, yeah? And what you simply do is this. At each of these values, you just draw a line. So at the minimum 2, I just draw a line like so. At Q, oh, I missed Q3, didn't I? So this should be right here. At Q3, I draw another line this way. At Q2, I draw another line this way. At Q3, I draw another line this way. And then at the max value, I draw another line this way. So I just drew one line at each of my 5 points. So I have 5 lines, correct? And this is what you do. For the outside, you draw the whiskers. So you just draw a single line connecting these two right here. Those are your whiskers. And then for your interquartile range, you draw a box instead, like so. And that right here is your box and whisker plot. Questions there. Questions there. So you just draw your 5 lines. You draw a whisker on the outside for your whiskers, and you draw a box right here. If you want to, you can name them. This right here is the minimum. This right here is Q1. This right here is Q2, and this right here is Q3. If you want to name them, but you don't have to. Question there. All right, so yeah. So like I was saying, for the rest of the class right here, you have this assignment to turn in. So just like the other one, you answer each of the questions, you take a picture, and then you turn that in. That's all we have to do for today.